The hagfish is older than bones. The animal in front of you is eating a dead whale at the bottom of the Pacific Ocean. It has burrowed into the carcass through the eye socket. It does not have a jaw. It does not have a backbone. It does not have any bones at all. It is roughly a meter long, gray-pink, and shaped like an eel that has not been finished. Its ancestors have been doing this exact thing, eating dead bodies on the seafloor for approximately 500 million years. This is a hagfish. The biological class is Myxini. There are about 85 known species, all marine, all bottom feeders. The one in front of you is Eptitretus stoutii, the Pacific hagfish, roughly average for the group. It has no jaw. Where its mouth should be is a small lipless opening with 2 rows of horn-like teeth on a rasping tongue. It has no scales, it has no proper backbone. The internal supporting structure is a flexible rod called a notochord, which is what vertebrates had before vertebrates had vertebrae. It has about 100 slime glands lined up along the sides of its body, each capable of producing a quantity of slime thousands of times the volume of the gland itself. We will get to the slime. First, we are going to walk back to the beginning. 500 million years ago, in a period geologists call the Cambrian, the ocean did not look like it does now. There were no fish in any sense that you would recognize. There were no sharks, there were no whales, there were no trees on land, there was no plant life on land at all. Animals had not figured out vertebrae yet. Most life on Earth was soft-bodied, jellyfish-like creatures, segmented worms, primitive arthropods called trilobites, and a few experimental body plans that did not survive past this period. In this ocean, a small eel-shaped animal with a flexible rod down its back appeared. It had no jaw, it had no bones, it had a simple feeding apparatus and a low-energy metabolism. It scavenged dead things from the seafloor. This animal is, as far as the fossil and molecular evidence shows, the ancestor of the hagfish. The branching point between hagfish and lampreys, the 2 surviving lineages of jawless vertebrates, happened roughly 500 million years ago. The branching point between this combined jawless lineage and the rest of the vertebrate tree happened a bit earlier than that. In other words, when the hagfish lineage and the human lineage split apart, neither one had a jaw, neither one had a real backbone, and neither one had any teeth. One of those lineages eventually got all 3. The other one decided it didn't need them. About 60 million years after the hagfish split off, other vertebrate lineages started developing 2 pieces of equipment that would define almost every animal in the ocean from then on. First, jaws. Around 440 million years ago, in the Silurian period, the first jawed fish appeared. A jaw is essentially a repurposed gill arch that hinged forward. It is an enormous evolutionary advantage. Suddenly an animal could bite, hold, and tear food. Predators could attack actively instead of waiting for things to die. Second, mineralized bone. Around 420 million years ago, in the early Devonian, vertebrates evolved the ability to deposit calcium phosphate in their connective tissue. This gave them internal skeletons that were stiffer, stronger, and lighter than the cartilaginous rods that came before. Bone allowed fish to get bigger and faster. For most vertebrate lineages, these 2 innovations were transformative. Jawed, boned fish exploded in diversity. Almost every fish you have ever heard of, sharks, eels, tuna, salmon, cod, goldfish, descends from this evolutionary moment. The hagfish lineage did not participate. The hagfish kept the rasping tongue, it kept the notochord, it kept the cartilaginous skull. It did not develop jaws, it did not develop bones. It looked at the new equipment its cousins were using and apparently decided that its existing job, scavenging corpses on the deep sea floor, did not require either of them. 252 million years ago, the worst extinction event in the history of life on Earth happened. Geologists call it the Permian-Triassic boundary. Estimates vary, but somewhere between 90 and 96% of all marine species went extinct in a window that probably lasted only a few tens of thousands of years. The cause is debated, likely a combination of massive volcanic eruptions in Siberia, the resulting climate disruption, and ocean acidification that crashed pH levels worldwide. Almost every major group of marine animals was either annihilated or reduced to a handful of struggling species. Trilobites, extinct. Most coral lineages, extinct. Most of the ammonite groups, extinct. Many shark families, extinct. The hagfish lineage did not go extinct. There is no fossil evidence that hagfish populations even noticeably declined during the Permian event. The animal was already specialized for eating dead bodies. The Permian extinction produced an enormous supply of dead bodies. From the hagfish's perspective, the worst event in marine history was, biologically, a buffet. The next 200 million years are what most people think of when they think of prehistoric oceans. The Mesozoic era contained marine reptiles the size of buses. Ichthyosaurs, plesiosaurs, mosasaurs. It contained ammonites with shells the size of car tires. It contained sharks larger than any shark alive today. Above the water, dinosaurs walked the land. The hagfish, meanwhile, was unchanged. We can actually verify this with a specific fossil. In 2011, paleontologists working in late Cretaceous limestone deposits from Lebanon found an exceptionally preserved hagfish, which they named Tethomyxine taparostrum. It is approximately 100 million years old. The fossil shows essentially the same body plan as a modern hagfish, the same eel-like shape, the same lipless mouth, the same arrangement of slime gland pores along the body. The fossil even preserved traces of slime threads. What this means is that 100 million years ago, while Tyrannosaurus rex had not yet evolved, and while flowering plants were still spreading across the continents, the hagfish was already doing exactly what hagfish do today: eating dead things on the seafloor, producing slime, likely tying itself in a knot to clean off the slime, though this we cannot prove from a fossil. 66 million years ago, an asteroid roughly 10 kilometers across struck what is now the Yucatan Peninsula. The impact created a global firestorm, blacked out the sun for years, collapsed photosynthesis-based food chains, and killed roughly 75% of all species on Earth, including all non-avian dinosaurs, all the large marine reptiles, all the ammonites, and most of the large sea-going fish. The hagfish, again, was unaffected at the species level. The deep ocean is buffered against surface catastrophe. The food supply for a corpse scavenger arguably increased. The thing about extinction events is that they tend to be hard on animals that are highly specialized for a specific living environment. The hagfish is specialized for a specific dead environment. When everything dies, hagfish does well. About 50 million years ago, in a geological period called the Eocene, a group of small land mammals related to modern hippos and deer began moving back into the ocean. Over the next 30 million years, they became whales. The largest whales reached body masses that exceeded anything in marine history. Modern blue whales weigh up to 180 tons each. When a whale dies, it sinks to the deep ocean floor. This is called a whale fall. The carcass becomes a localized food source that supports an ecosystem of scavengers for years to decades. The hagfish was one of the first species to specialize in colonizing whale falls. A modern whale fall typically attracts thousands of hagfish within hours of the carcass landing on the sea floor. They burrow into the body through any available opening. They eat from the inside out. Some of them remain on a single whale fall for years. The food supply just got bigger. Today, the hagfish you are looking at is doing the following things. It is hunting by smell. It cannot see well. Its eyes are vestigial, partially covered by skin. It does not need them. It tracks the chemical signatures of dead tissue across the sea floor. When it finds a corpse, it enters through the softest available opening. It eats from the inside, including by absorbing dissolved organic compounds directly through its skin. If a predator approaches, it produces slime. The slime expands 10,000 times its initial volume on contact with seawater. It clogs gills. It can drown a fish in seconds. After the predator dies or leaves, the hagfish ties itself in a knot and slides the knot down its body to clean off the slime. The hagfish is older than bones. The hagfish is older than jaws. The hagfish is older than trees. The hagfish is older than the asteroid that killed the dinosaurs by hundreds of millions of years. Most species respond to mass extinction events by changing or dying. The hagfish has responded to 5 of them by not changing. It is a load-bearing piece of the deep ocean's cleanup system. It will probably still be doing this when humans are not. If you watched all the way through, hit subscribe. Next week, the parasite that becomes a tongue.